Every time you get behind the wheel, you're trusting four small, completely hidden parts to keep you rolling safely down the road. They are the absolute unsung heroes of your car, the wheel bearings. So today, we're going to pull back the curtain and see how these tiny powerhouses make all of modern transportation even possible.
I mean, just stop and think about that for a second. A 2-ton vehicle, that's 4,000 pounds, flying down the highway. The wheels are spinning hundreds, maybe thousands of times a minute. All of that weight, all of that speed is focused on these tiny little points of contact. If you didn't have the right engineering, the friction would be so insane that metal parts would literally weld themselves together. The solution to this problem is, well, it's just an incredible piece of thinking.
So, to solve that huge physics challenge, engineers used a device that's been perfected over centuries. But before we get to how it works inside your car, we kind of have to understand the basic idea. So what is a bearing anyway?
Okay, in the simplest terms, a bearing is an anti-friction machine. It's the secret sauce that makes a sliding door feel weightless, or lets a shopping cart glide effortlessly down the aisle. Its whole job is to let parts move smoothly, but only in the way they're supposed to, while declaring an all-out war on friction.
And this really gets to the heart of it. Without a bearing, you've just got two pieces of metal grinding against each other. That creates a ton of friction, a ton of heat, and things wear out fast. But with a bearing, you stick some rolling things in between them. That one simple change stops the metal-on-metal contact, friction just plummets, and suddenly you need way less energy to make something move. This is the core principle that makes everything in our world fast and efficient.
All right, so now that we've got the basic idea down, let's see how it gets applied in one of the most brutal environments you can imagine, inside the wheel of your car.
See, a wheel bearing isn't just there to help the wheel spin. Not at all. It's juggling like 4 critical jobs all at the same time. It's holding up a quarter of your car's weight, it's fighting off these powerful side forces every single time you turn a corner, and through all of that, it has to keep the wheel spinning buttery smooth and pointed in exactly the right direction. It's an incredible balancing act. And let's break down those forces it's dealing with. You've basically got two kinds. The first is radial load. That's the constant crushing weight of the car pushing straight down. But then you have axial load, or thrust load. That's the intense side-to-side force that hits the wheel every time you steer into a corner. A wheel bearing has to be a master of handling both of these, simultaneously, without breaking a sweat. So how in the world does this one small component handle such extreme punishment? Well, to figure that out, we've got to take a look inside.
Everything starts with what we call the races. Just picture two perfectly smooth steel rings, like a track. One ring is nested inside the other. The inner race is connected to the part that's spinning, your axle, while the outer race is fixed to the part that's holding still, which is your car's suspension. And sandwiched in the track between those two races, you find the real workers, the rolling elements. These are either perfectly round steel balls or little cylinders called rollers. And they're kept perfectly spaced out by something called a cage, which is kind of like a separator that makes sure they don't all bunch up on one side. So here's the magic. Instead of those two metal races grinding directly on each other, which would be sliding friction and really bad, they're separated by these little guys that roll. This one trick converts nasty, high-energy sliding friction into super efficient, low-energy rolling friction. It's the difference between trying to drag a heavy filing cabinet across the floor versus putting it on a dolly with wheels. I mean, it's a night and day difference. But, not all rolling elements are created equal. The type you use makes a huge difference. Ball bearings, for instance, make a teeny tiny point of contact with the races. That means incredibly low friction, which is perfect for high-speed cars. On the other hand, roller bearings make a line of contact. This spreads the load out over a much bigger area, which gives them a way higher load capacity. That's why you find them in big trucks and heavy-duty vehicles. And just like every other piece of technology in your car, wheel bearings have not been standing still. Oh no, they have evolved like crazy over the years, becoming way more reliable and a whole lot easier to deal with. This whole evolution has been about one thing: integration, making things simpler and more reliable. We started way back with Gen 0 in old cars. This was two separate bearings that mechanics hated. You had to constantly grease them and do this finicky adjustment to get the tension just right. Then Gen 1 came along and sealed the whole thing into one cartridge. Huge improvement. Then Gen 2 made life even easier by building the bearing right into the wheel hub. And what we have today? Gen 3 is the peak. It's a complete bolt-on unit with the hub, the bearing, and even the sensor for your anti-lock brakes all in one piece. It's gone from a tricky mechanical job to basically a plug-and-play part. Okay, so this brings us to something really practical. These bearings are designed to last a long, long time, but they aren't invincible.
So how do you know when one is starting to go bad? Well, you have to use your ears. You have to listen to your car.
The number one classic symptom is a humming, growling, or rumbling sound. You'll notice it gets louder and higher pitched the faster you go. And here's the dead giveaway. If the noise changes or gets worse when you turn the steering wheel left or right, that's a huge clue. You might also feel a vibration to the steering wheel, and because so many new bearings have that brake sensor built in, a failing one can even switch on your ABS warning light.
So it's making a little noise. Is that really a big deal? Can't you just turn up the radio? The answer is a huge, emphatic yes, it's a big deal. That little noise isn't just an annoyance, it's a critical warning sign that you absolutely cannot ignore.
Let's be crystal clear here. A failing wheel bearing is a major safety issue. That wobble you feel messes with your steering and can make your braking less effective. Your ABS system could just quit working when you need it the most, and in the absolute worst-case scenario, the bearing can fail completely, causing the wheel to lock up or even detach from the car while you're driving.
And this quote really just nails it. They are essential components that directly affect safety, handling, and comfort. Think about it. Every single aspect of your drive, from how smooth it feels to your ability to steer out of trouble to stopping in an emergency, it all rides on this tiny, hidden part working perfectly. It is the literal link between your car and the road.
So, the next time you're driving down the road, just listen for a second. That smooth, quiet sound of your tires on the pavement, that's the sound of some incredible, unseen engineering doing its job perfectly. And it really makes you wonder, doesn't it? What other invisible technologies are out there quietly keeping us safe every single day?